OpenAI says GPT-5 is a major leap in reasoning. They showed demos. They showed benchmarks. And everyone shared the results. But I wanted to know what happens when someone outside OpenAI runs those exact same tests. So that is what I did, and that is what you are about to see. Before we get into the results, let me be clear about what this video is and what it is not. This is not a hit piece on OpenAI. It is also not a hype video. It is a straightforward look at whether the GPT-5 reasoning improvements reproduce when you test them honestly, without controlled conditions and without cherry-picked prompts. Here is what OpenAI actually claimed. During the GPT-5 launch, their team highlighted 3 categories of reasoning improvement: multi-step math problems, logical deduction tasks, and code generation that requires understanding intent rather than just syntax. They showed side-by-side comparisons where GPT-4 gave wrong or incomplete answers and GPT-5 got them right. I pulled those specific examples from the launch materials, reconstructed the prompts as closely as possible, and ran them fresh. No system prompt manipulation. Default temperature. The same way most users would actually interact with the model. Let me walk you through each one. The first test is the math problem. OpenAI showed a multi-step word problem that involves a rate calculation embedded inside a probability question. GPT-4 in their demo set up the right equation but made an error partway through and returned the wrong number. Let me show you what both models returned when I ran this prompt. GPT-5 got the correct answer. More importantly, the chain of thought it showed was clean. It identified the subproblems in order, solved each one, and carried the right values forward. GPT-4, run at the same time, made the same type of error OpenAI showed in the demo. That result reproduced accurately. Point to OpenAI on this one. Now the logic puzzle. This one was a variation on a classic constraint satisfaction problem. 5 entities, 5 attributes, a set of conditional rules, and a question about a specific entity. These types of puzzles are a common benchmark for reasoning because they require holding multiple rules in working memory at the same time. GPT-5 solved it correctly and showed its reasoning step by step. It eliminated possibilities systematically. GPT-4 got the final answer wrong, though it built a mostly correct constraint table before making a logical jump it could not justify. The failure mode was the same as what OpenAI showed. Again, the demo result reproduced. The coding challenge is where things get more interesting and more complicated. OpenAI's example showed GPT-4 writing functional code that missed the underlying intent of the request. The user asked for a function that handles edge cases automatically, and GPT-4 wrote code that only handled the obvious path. GPT-5 on the same prompt wrote a function that included edge case handling, added a brief comment explaining the reasoning, and structured the output in a way that is easier to extend later. That is a real difference. It is not just syntax. The model understood what the developer would likely need next, not just what the prompt literally asked for. But here is where I started going off script. I ran a harder version of that coding challenge. Instead of a clear task with an implied edge case, I gave both models an ambiguous requirement with 2 equally valid interpretations and no indication of which one the user wanted. GPT-5 picked one interpretation and ran with it confidently. It did not ask for clarification. It did not flag the ambiguity. It just chose. Sometimes that is fine. But in a real development context, choosing the wrong interpretation and writing 30 lines of code around it costs time. GPT-4 did exactly the same thing. Neither model flagged the fork in the road. I ran this ambiguity test across 5 different coding prompts. GPT-5 asked for clarification in 1 out of 5. GPT-4 asked 0 times. So GPT-5 is marginally better at recognizing when it needs more information, but this is still a genuine gap between what the model can do and what a careful human developer would do. Let me talk about the side-by-side comparison more broadly. Across all the tests I ran, GPT-5 outperformed GPT-4 on tasks that required structured multi-step reasoning with a clear correct answer. The improvement is real and it is consistent. But the gap is not uniform across task types. For open-ended creative reasoning, the difference is smaller. For tasks where ambiguity matters, both models have the same blind spot. There is also a speed consideration that rarely comes up in benchmark discussions. GPT-5 takes longer to return answers on complex reasoning tasks because it is doing more work. In interactive use, that pause is noticeable. Whether that trade-off is worth it depends entirely on what you are building or what you are trying to get done. So what does this mean for you if you are deciding whether to use GPT-5? If your work involves structured reasoning, step-by-step problem solving, or code generation where correctness matters more than speed, the upgrade is genuinely worth it. The reasoning improvements OpenAI claimed are real. I could reproduce them. If your work is more about generating drafts, brainstorming, or tasks where the output does not have a single right answer, the practical difference will feel smaller day to day. You will notice improvements in certain moments, but it will not feel like a completely different tool. And if you are a developer who relies on the model to understand your intent rather than just your instructions, GPT-5 is a step forward, but it is not a replacement for clear prompting. The ambiguity problem is still there. Build your workflows with that in mind. The broader lesson from this test is about how to evaluate AI model claims in general. OpenAI showed you cases where GPT-5 wins. That is expected. What matters is whether those wins reproduce outside their environment, and whether the failure modes they did not show are failures that would affect your specific use case. Always test on your actual tasks. I will keep running these tests as GPT-5 rolls out to more users and as the model is updated. If the reasoning behavior changes significantly, I will cover it here. The goal is always to give you an accurate picture of where AI tools actually stand, not where the press releases say they stand. If this kind of honest, hands-on AI testing is useful to you, hit the like button. It helps this channel reach people who want real analysis instead of hype. Subscribe so you do not miss the next video, where I am testing whether GPT-5 handles long context tasks better than the competition or whether the context window improvements are mostly marketing. That one might surprise you.